class, welcome back to class. I'm super excited to have you guys back to class again. Of course, we have something to share in this video today. Now we are going to be looking at exponential functions, which is also known as Indicia equations. There are equations that are possible with indices, where we have one function equal to the other, and you are asked to find the alphabet, the variables. Now, to this aspect, there are two major rules that are applicable. One is much vital, but there are two major rules that are very important for us. All right, there are other rules, but these two laws must be known. Number one law is if s raised to power a is equal to s raised to power b. You know, in normal indices, we used to have this as s raised to power a multiplied by s raised to power b, but in this case now, this has been replaced with equal to. Are you seeing now? This has been replaced with equal to. So now, when you have two index forms separated by equality sign, when you have one to the left and have the other to the right, please pay attention to this. What you also watch out for is their base. That is rule 1. When their bases are equal, all you need to do is to cancel out the base. What is left here is their power. So you will cancel the base and equate the powers. Listen carefully. So that is law number 1. Rule number 1 states that if s raised to power a is equal to s raised to power b, which shows that equal base, then cancel out the base and equate the power. This is rule number 1. When the bases are equal, you stroke out the base. Then what is left are the powers. So equate the powers. Then simplify. Get the answer for the unknown variable. Then rule number 2 states that there are some values you will be given, yet will not be able to what? Have the bases to be equal. But in this case now, the powers will now be equal. So what you do is to what? Cancel out the power and equate the base. So the one that is equal is the one you cancel out. So in law 1, the bases are equal, so you cancel out the base. In law 2, the powers are equal, then you cancel out the power. So in this case, you see that this is a raised to power s is equal to b raised to power x. So anytime the power is equal, then you can cancel out the power. But these theories are only used, listen carefully, when you have only one term to the left hand side or one term to the right hand side. So if you are given multiple terms at any of the sides, you must simplify it to a point where you will have only one base to the left and only one base to the right. Otherwise, you cannot use these laws. Law 1 or law 2 can only be used at a point where you have only one base to the left and only one base to the right. If you have two bases to the left and one base to the right, you cannot use it. You must ensure that both sides has one base each. This is the ground to which you can apply either law 1 or law 2, depending on the value. If the value is possible to have equal base, then law 1 is suitable. If it is not possible, but we can deduce this to have equal powers, then we are good to go. This is all about this. Now, get it clear. So I want to quickly give you the conditions to which you use law 1 and law 2. Now, when you have numbers as the base, for instance, I have this now, I must ensure that I what? Make the base equal base, because the unknown is at the numerator, is at the power. So when the unknown appears as a power, you find a way to make the base equal. Hope you can see now. So in this case, you see that the base here, they are what? Numbers, while the power is a variable or a letter. So anytime you have the base as numbers, all you just need to do is to find a way to make the base at both left hand side and the right hand side equal. But when you have it in this way, and then I have something like this, all I need to do is to make the what? The powers the same. Are you seeing it now? So when you have the unknown as the base, you cannot make the base equal. You can only make the powers equal. So you make the base equal when the unknown is at the index. While you make the power equal when the base is the unknown. Are you there? So when the unknown occupies the power, you make the base equal. And when the unknown occupies the base, you make the power equal. Are you there? I take it again. When the unknown occupies the position of the power, you make the bases equal. But when the unknown stands in the position of the base, then you find a way to make the powers equal. So the base is made to be equal when the unknown is at the power, while you make the what? The powers equal when the unknown occupies the base. This is the condition. So for this, you make use of this when the unknown is occupied at the position of the power, while you make this when the unknown is serving as the base. I have number 1, 2x is equal to 16. Now, when you look at this question, the first thing you must do is to watch out the position of the unknown. Now, the position of the unknown is at the power. Anytime the unknown occupies the power, you make the base equal. You find a way to ensure that the base at both ends are equal. And anytime you have the base to be the unknown, you make the powers equal. But in this case now, the base is integral, while the unknown is at the power. So anytime the unknown is at the power, all you need to do is to find a way to make the base equal. So now I will come to the left hand side. At the left hand side, the base there is 2, which cannot be reduced further. I will pull down 2. Then, since the minimum base at the left hand side is already 2, that means at the right hand side, we must have the same base. So put down this base. All I just need to do is to find what we 2 raised to that will give us 16, or better still, just come here, have 16 divided by 2. And that will give us what? 8. 2 here, 4. 2 here, 2. 2 here, 1. So 2 in 4 places. It's as simple as this. So at this point, what we have now is equal base. And when you have equal base, cancel out the base, then equate the powers. Therefore, x is equal to 4. This is the answer to this question. Now, when we look at question number 2, Roman figure 2, we have 5 raised to the power x. 5 raised to the power x plus 1 is equal to 625. This is the result that we have here. So the first thing you do is to ascertain the position of the unknown. Now, in this question also, the unknown occupies the power. Are you there? Yes, the unknown, which is the variable here, x, is at the power. So that means anytime I have the unknown at the power, I will find a way to make the base equal. Now, at the left-hand side, the base there is 5, and is the only base. At the right-hand side, the base there is 625, and is the only base. So what must I do now? The first thing is, can I reduce 5 to another smaller base or a lower base? No. So I will put down 5, x plus 1 is equal to, now that I know I cannot reduce this, I will equally put down 5 here. Then I will now divide 625 by 5. So if I have this 625 divided by 5, 625 divided by 5 would have given us 125. Now 125 divided by 5 would have given us 25. Now 25 divided by 5 will give us 5, and 5 divided by 5 is 1. So 5 in 4 places. This would have given us 5 raised to the power of 4. Now the next thing we are quickly going to do, now that we have equal base to the left hand side and to the right hand side, all I just have is state equal base. Then anytime you have equal base, what do? You simply cancel out the base and equate the power, which is x plus 1 is equal to 5. Cancelling out the base, you find out that the powers that we equated gave us what? An equation, which is linear equation. So what do we do here? All we simply need to do is to make x the subject of formula, because we are actually looking for the value of x. That when we add 1 to it, it will give us 625. Are we there? So we will have this as x is equal to 4. When plus 1 crosses from the left to the right, it becomes minus 1. Therefore, x is equal to 3. This is the answer to this very question. Now, the next thing we are quickly going to do, if you want to validate whether your answer is correct, all you just need to do is to substitute 3 here. So this would have been 5 raised to the power 3 plus 1, and 3 plus 1 is 4. And 5 raised to the power 4 is 625. That shows that you are correct. Now let's look at question number 3. We have 8 raised to the power x is equal to 32. Now similarly, in this question, we find out that the unknown occupies the power. And anytime the unknown occupies the powers, all we just need to do is to find how we can possibly make the base of both sides equal. And now we have one term to the left hand side and one term to the right hand side. So, what must I do? Can I reduce it further to another simpler base? Of course, yes. 2 raised to power 3 is 8. Alright? So we will have this as 2 raised to power 3 all raised to power x. Now what about 32? 32 is 2 raised to power 5. 2 multiplied itself 5 times will give us 32. Then this will have given us 2 raised to power 5. Then finally we can open the bracket using the what? The fifth law of indices, which is what? The product power law. Are we there? Yes. So when we multiply 3 by x, we are going to have 2 raised to power 3x is equals to 2 raised to power 5x. Now we have equal base. Now, anytime you have equal base, what do? You cancel out the base and equate the power. And what are the powers here? 3x is equal to 5. Now we are looking for x, not 3x. So what must we do? X has a coefficient of 3. All we simply need to do now is to divide both sides by 3. And when we divide both sides by 3, we will have x is equal to 5 over 3, which is same as 1 whole number, 2 over 3, if we want to convert to mixed fraction. Then we are done with question number 3. Number figure 4, we have V. We have 16, 3 minus x is equal to 1. This is what we have. This is very simple. You can reduce 16 to its least base, which would have given us 2 raised to power 4. But I don't need that here because at the right hand side, I have 1. And I already know that in this case now, the unknown is at the power. That means I need to make the base equal. What must I do to 1 to have it to this base? Recall equation 3 in indices, law number 3, which says that anything raised to the power of 0 is 1. That means I can replace this 1 by 16 raised to power 0. It's as simple as that. There is no need for me to break this down. Again, except I have a larger number here that I can break down. In as much as this is 1 that we have there, all I just need to do is to apply law 3 of indices that anything raised to the power of 0 is 1. Therefore, I will simply have this as 16 raised to power 3 minus x is equal to what? 16 raised to power 0. We just replace 1 with 16 raised to the power of 0 because anything at all raised to the power of 0 is 1. So 16 raised to power 0 is 1 equally. Then at this point now we have equal base. And now that we have equal base, we cancel out the base. We have 3 minus x is equal to 0. And now we are looking for x. So we need to make x solid of formula. And this will have given us x. When we take plus 3 to the right hand side, it becomes minus 3. And what's the next thing we do? We simply divide both sides by minus 1 because this is minus 1x so that we can find positive x. So this will have given us x is equal to minus 3 divided by minus 1. And guys, minus divided by minus is plus and 3 divided by 1 is 3. Then we have this as our answer. Indicia equations are easier to solve when you understand the rules, the principles. It's as simple as that. So you must understand that when the unknown is at the power, find a way to make the base equal. That's all. Okay, now we have the very last question on the board. We have it as 27 x plus 2 is equal to 9 2x. Similarly, at the left hand side here, I have one base. X plus 2 is the power of 27. And at the right hand side, I have one base. What must I do? The next thing is, I will now check out where is the unknown. The unknown occupies the position of the power. That is to say, I will find a way to make the base equal. That's all. So what must I do now to make these two bases equal? Of course, I can reduce 9 to another least value that can raise to another number. Is that correct? Similarly with 27. So what I need to do now is 2 cannot divide 27 and 2 cannot equally divide 9. So we move to 3. Now, 3 can divide 27 and can divide 9. And 3 raised to power 3. 3 raised to the power of 3, guys, would have given us 27. So we replace 27 by 3 raised to power 3 and put down the power. Is equal to 9. Will also give us what? 3 raised to power 2 multiplied the existing power. So this is the existing power of 27. Why everything here, 3 raised to the power 7 is 27. This plus 2 that we have in bracket is the old power of 27. Similarly, when we come here, 9 is 3 raised to the power 2, and the existing power is 2x. And that's exactly what we have in the bracket here. All we need to do now is to what? We can cancel out or first remove the bracket. Alright? So let's multiply out. This will have given us 3. 3 multiplied by x will give us 3. And 3 multiplied by plus 2 will have given us 6. Is equal to 3, which is the base. 2 times 2x will give us 4x. Now we have equal base. And now anytime you have equal base, cancel out the base and equate the powers. Now the powers here is 3x plus 6 at the left hand side and 4x at the right hand side. All we simply need to do is to collect like terms. And to collect like terms, now we are going to have this as 3x minus 4s. As plus 4s crosses from the right to the left, it turns to minus 4. And as plus 6 crosses from left to right, it turns to minus 6. Now, when we remove 4s from 3x, we are going to have minus 1x, which is equivalent to minus 6. And we are not going to leave our answer as minus 1x, so we are quickly going to divide both sides by minus 1. And therefore, when we do that, we are going to have x is equal to minus 6 over minus 1. And minus divided by minus is plus, and 6 divided by is 6. This is the answer to this very question. It's as simple as this, guys. So simple. Very simple. So simple. So now, the next thing we are going to do is to look at equation. Look at what question number 2. So guys, if you find this content helpful, do consider subscribing to this YouTube channel if you have not done so, and ensure that you turn on the post notification bell for more exciting videos. Don't forget to refer your friends to this platform, share this video, and ensure that you like this video. Make your necessary comment. We love you guys. See you in the next. Now, on the board, which this happens to be question number 2, we are asked to solve the following equations. Alright, we are asked to solve the following equation. Now we are asked to solve the following equation. But we'll put down one question here. So we are solving this right away. Now we have 2 multiplied by 4x minus 3 is equal to 16x divided by 8, 1 minus x. Now the first thing we do here, guys, is to identify the position of the unknown. And here the position of the unknown is at the power. That means we find a way to make the base equal. And now when we come to the base, we discover that at the left hand side, we have 2 times 4. That means we do not have one base here. And equally, when we come to the right hand side, we have 16 raised to the power s divided by 8. Raised to the power whichever powers it has. Are we there? So it shows that we cannot directly cancel out the power now until we simplify the left hand side to have one base, and also simplify the right hand side to have one base using any of the laws of indices. Now, so what do we do? I know that any number without power has the power of 1. So for me to have common base between this and this, I need to reduce 4 to 2. Is that correct? Yes, as simple as this. So this would have given us 2 raised to the power 1, and 4 is 2 raised to the power 2. Multiplied by what? X minus 3. 2 raised to the power 2 is 4. Then this is the initial power of 4. Then is equal to 16. Now we already reduced the left hand side to base 2. That means we equally need to reduce the right hand side to base 2. We don't need to think of any other number. In as much as we already have base 2 at the left hand side, the right hand side will equally be to base 2. Otherwise, this equation will not be true. Then we have this as 2 raised to the power 4 will give us 16 divided by 2 raised to the power 3. Divided by 2 raised to the power 3, 1 minus x. So we need to simplify. Between this and this now, we have equal base, and their connection is multiplication. So we are going to use the first law of indices. So we will pick one base, add up their powers. Now 2 multiplied by x is 2x, and 2 multiplied by minus 3 will have minus 6. So we already have one base at the left hand side. We are still going to do the same at the right hand side. So we have 2 bases here that are connected with what? Division sign. So we pick one of the bases. Then the first power will be 4 times s, which is 4x. The other power will be what? Minus 3 multiplied by. Now, 3 multiplied by x is 3, and 3 multiplied by minus x is 3x. So 3 multiplied by 1 is 3, and 3 multiplied by minus x is 3x. So this will now be in brackets. Now the next thing we are quickly going to do is to simplify the power before we cancel out. So between 1 and minus 6, we are going to have minus 5. Therefore, this will have given us 2x minus 5 is equal to, at the right hand side, we put down the power. This will have given us 4x minus times minus 3. Minus times 3 will give us minus 3, and minus times minus 3x will give us plus 3x. At this point, this will have given us 2x minus 5 is equal to 2. 4x plus 3x will give us 7x minus 3. At this point now, we have equal base. And anytime you have equal base, cancel out the base, then equate the power. Don't always forget that before you can cancel out the base, you must ensure that you have only one base to the left hand side and only one base to the right hand side. Now at this point, we will now equate the power where we have 2x minus 5 is equal to 7x minus 3. Now this has landed us in what? A linear equation. And if you are not good with linear equation, guys, please check our playlist. Now at this point, all we need to do is to collect like terms. And by collection of like terms, we mean all the variables should be at the left hand side and all the constants should be taken to the right hand side. Therefore, I have 2x. When plus 7x crosses from left to right, from right to left, we have 7x, put that equal to minus 3. And when minus 5 crosses from the left to right, it becomes plus 5. Now when we remove 7x from 2x, this will have given us minus 5x, which is equivalent to, now when we add 5 to minus 3, this will have given us 2. We are looking for the value of x, not minus 5x. So what do we do to remove this minus 5x? We are simply going to divide both sides by minus 5. Therefore, this will have given us x is equal to minus 2 over 5. By dividing both sides by 5. This is the answer to this very question number 2. So very quickly, we are going to look at question number 3, guys. Now we have question number 3 on the board. So we are asked to solve 3 multiplied by 9 raised to the power 1 plus x is equal to 27 raised to the power of minus x. So at first we identify the position of the unknown, and the position of the unknown here is at the power. That means we will now find a way to make the base equal. That's how it is. Alright? So what do we do now? When we check the left hand side, we discover that we have 2 bases. And on the right hand side we have 1 base. So what are we going to do? We know that before we can apply law 1, we must ensure that the base at the left hand side and at the right hand side are all 1 to base 1. Now, so we are going to first of all simplify the left hand side to have 1 single base, not 2 bases like we have here. So how do we do that? We know that these 3 cannot be reduced further, and the same thing as 3 raised to the power 1. Then multiply by, now we will also convert 9 to base 3 if possible. Of course, it's possible. 3 raised to the power 2 will give us 9 into existing power of 9. Then equal to, now that we already have base 3 to the left hand side, we are equally going to have base 3 to the right hand side. This is that. You don't need to stress yourself. All you just need to do now is what with 3 raised to, that will give us 27. 3 raised to power 3 is 27. So we have 3 multiplied by the existing power, which is minus x. Now here we can now pick one of the base, which is 3. Then the first power is 1. If this is multiplication turns to addition, then we can multiply out this bracket. Now 2 times 1 is 2, and 2 times s is 2x. So we have 2x is equal to 3 raised to the power 3 times minus x is minus 3x. At this point now, this guy plus this guy will have given us 3. So this will have given us 3 raised to the power 3 plus 2x is equal to 3 raised to the power minus 3x. What happens here now? Equal base. And what do you do when you have equal base? All you simply do is to cancel out the base and equate the power. So the base cancel the base, then we will equate the powers. Minus 3x. And what's the next thing we do now? This is a linear equation. All we need to do is to collect like terms. Take all the variable to the left hand side and take all the constant to the right hand side. And by so doing, We have 2x at the left hand side. When minus 3x crosses from right to left, it becomes plus 3x. And when 3, positive 3 crosses, it turns to what? Minus 3. So when we add 3x to 2x, this will have given us 5x minus 3. And we cannot leave our answer like this, so we are quickly going to divide both sides by 5 so that we can have the coefficient of x1. And when we do that, this will give us minus 3 over 5. Now we have the proper fashion. Will we stop here? It's as simple as this, guys. This is Indicia equation, or what you call exponential indices, right? Now let's quickly look at question number 4 on the other side of the page. Let's get to work, guys. Now, this is our solution. And we have 2 raised to power x is equal to 0.25. And like we had earlier, we have decimal base and decimal powers. And we said that anytime you are having decimal base or decimal powers, you must convert them to their respective fractions. Are we there? So now we have 0.25. Before we can solve 0.25, we cannot solve in decimal. So we need to convert this to fraction. And what is the fraction? What is the fraction equivalent to 25? How do you get that? First, you put down the number there, which is 25. Then this decimal point turn it to 1. And how many values do you have after decimal point? 2 digit numbers. So you have this. Also, how many decimal places do you have that to be? That's 2 decimal places. That will give you the 2 zeros that we have there. This would have given us 25 over 100. And 25 over 100 in this platform is 1 over what? 4. 25 into itself is 1. And 25 into 100 is 4. Alright? Then this would have given us 32 raised to power this is equal to 25 over 100. Then we reduce this to 32. X is equal to 1 over 4. Now, guys, what are we going to do here to be able to make this linear? This is a fraction. Now, understand that anytime the numerator is 1, you can always use the fourth law of indices, which is stating as this. So, if I have x raised to power minus 1, it is stating as 1 over x. So, if I have 4 raised to power minus 1, it is stating as 1 over 4. So, I'm going to convert this 1 over 4 to what? A negative power format. Are we there? It's as simple as that. So that we can make this equation linear. Another person can say, no, I don't want to do it that way. Let me cross multiply. When I cross multiply, I'm going to have 4 multiplied by what? 32 times 32s raised to power x equal to 1. Then at the end, I will not find anything raised to power 1. 0 is 1, right? But in this case now, we want to convert to this negative power. Then, this will have given us 32x is equal to 4 raised to power what? Minus 1, using the fourth law of indices. That 1 over 4 is equal to what? 4 raised to power minus 1. Now, at this point now, we have one base to the left and one base to the right. What do? We simply find a way to make their base equal, since the unknown is at the power. So, what must I do to this? Of course, 2 raised to power 5 will give us 32, and 2 raised to power 2 will give us what? 4. It's as simple as 2 raised to power 2 will give us 4. So 5 times x, this will give us 2 raised to power 5x is equal to 2 raised to power 2 times minus 1. This would have given us what? Minus 2. Now we have equal base. And when anytime you have equal base, what do? You cancel out the base and equate the powers. Now, what do here? We cannot leave this as 5x equal to minus 2. So we simply divide both sides by 5. And we have this as minus 2 over 5. This is the answer to this very question. Guys, if you find this content helpful, please share. Don't forget to like this video and ensure you invite your friends to this platform where you can learn and learn. On the board, we are asked to solve the following equation. Now we have Roman figure 1. And we have 2s cubed is equal to 54. Now, in this case, what we do is to assess this equation. When you assess this equation, you will discover that the unknown is at the denominator. You will see that the unknown is a base. Unlike the problems you solved before, in this case, you see that the unknown occupies the position of the base. So how do we solve problems like this? And also ensure that the coefficient of the unknown is 1 for you to be able to what? Use law 2. Are you there? So the coefficient of this and this guy now is 1. Therefore, I need to what? Divide both sides by 2 to make the coefficient of the unknown 1. Therefore, I'm going to have this as x cubed is equal to 54 over 2. Now guys, when we divide 54 by 2, this would have given us 27. Alright? Now, this is 3 as a power. This is base x. There's no way we can convert 27 to have base x. But we will find out now whether we can convert 27 to a number that will have a power of 3, so that we can apply law 2 where the powers are equal and we will cancel out the powers to equate the base. At this point, 3 raised to power 3 is 27. That means I can replace 27 with 3 raised to power 3. Therefore, this would have given us x raised to power 3 is equal to 3 raised to the power of 3. What does happen now? Equal powers. Or equal index, whichever case you want to put it. So in this case now, power cancel power, x becomes 3. We equate the base. There is no further simplification. That's how it is. But another way around, you can say x cubed is equal to 27, then x is equal to the cube root of 27, and you have 3, right? But we want to solve this question using indices format. That's the reason why we go through this process. So if any way you go through, you have the same result. Of course, it's 2 steps per each. Alright, now we have the next question on the board, which is question number Roman figure 2. And that Roman figure 2 happens to be what? X raised to power minus 1 over 2 is equal to 5 raised to power 1. Alright? Now, the unknown is occupied at the base. And now this is 5. There is no way we can reduce 5 to have a power of minus 1 over 2. So what must we do in this case? All we need to do is to eliminate this power. And to eliminate this power in fractional form, just invert it and multiply it with both sides. That's all. So all I need to do now is I will multiply the power of both sides by this power, the inverse of this power, and the inverse will be minus 2 over 1. So anytime you want to clear up fraction as a power when solving an equation, all you need to do is to take the inverse of that fraction and use it to multiply both the power at the left and the power at the right hand side. If this is done, then you have been able to successfully clear off the fraction. So at this point, I'm going to have x raised to power minus 1 over 2 multiplied by minus 2 over 1 is equal to 5 raised to power 1 multiplied by minus 2 over 1. This is all about this. There are so many ways to solve this, but I prefer this method. All we just need to do now is power multiplies power. We are going to have minus 1 times minus 2 will give us 2. 2 times 1 is 2 is equal to 5 raised to power 1 times this guy is minus 2 over 1. So 2 divided by 2, we have this to be 1, which this have given us what? 5 raised to power minus 2. And x raised to power 1 is the same thing as x. Now, what's the final thing we are going to do now? We cannot leave our answer having a negative value. So we are going to use law 4 of indices, which is negative power law. And the negative power law states that if I have s raised to power minus a, it's the same as 1 over s raised to the power of the same. Are we there? So we are going to have this as 1 over 5 raised to the power of positive 2. And 5 raised to power 2, guys, means 5 multiplied by 5. And 5 multiplied by 5 is 25. So the final answer to this is equal to 1 over 25. There are other 2 ways you can solve this same problem, but I only want us to start wasting our time. But you can get yourself used to this, that to eliminate power, fractional powers, all you just need to do is to multiply both the left hand side and the right hand side, their powers, by the inverse of, or the reciprocal of the original power. That's all. Now, we want to look at the last but not the least, which is Roman figure 3. So in Roman figure 3 now, here we are asked to solve Roman figure 3. We are asked to solve 5x is equal to 40x minus 1 over 2. Alright, now when you look at this equation, you find out that we have x in both sides. Are we there? Yes, we have x in both sides. So for you to be able to find this, you must ensure that you have x in one side. And if you decide to collect like terms now, the relationship between this s and this other s will be subtraction, which is not part of any of the laws of indices. So what must I do here now? The first thing I will do is to ensure that I reduce the coefficients. Now this is 5, this is 40, and 40 is divisible by 5. So let's first of all divide both sides by 5. Now this will have given us 5x over 5 is equal to 40x raised to the power minus 1 over 2 over 5. And this will have given us x is equal to what? 8x minus 1 over 2 plus 40 divided by 5 would have given us 8. At this point now, I want to eliminate this x raised to the power minus 1 over 2 from the right hand side. What could be the possible step to take to eliminate s raised to the power minus 1 over 2 from the right hand side? Because we only need s to appear in one of the sides, which is the left hand side. So how do we move this x to this side? Somebody can say, okay, let's divide both sides by this. Another way around is to multiply both sides by this. Are we there? Yes. So instead of dividing, you multiply both sides by what? The reciprocal of this, inverse of this. As simple as that. All I just need to do now is to say multiply both sides by the reciprocal of this. Are we there? So to multiply both sides by x raised to the power 1 over 2. Positive of this. Now, if this is negative, since you want to multiply, you must multiply with what? Opposite sign. So if this is positive, we will multiply with negative. Now that this is negative, we will multiply with positive. This is the only way we can eliminate, because we want to eliminate x raised to the power minus 1 over 2 from the right hand side, because we want s to appear only in one side. So to eliminate this, all we just need to do is to multiply by the opposite what? Index. Therefore, this will have given us x raised to the power 1. Don't forget that x is s raised to the power 1, then times s raised to the power 1 over 2. This is what we are multiplying both sides with, is equal to 8 times x raised to the power minus 1 over 2, which is this existing one, and then multiply by this s raised to the power what? 1 over 2. This and this will cancel, but let's work it out so that you know how they cancel. But understand that once you multiply, you can cancel out this and this. But let's work it out, okay? So this will have given us, now we want to use the law of indices here. The base are equal, so we pick one base and add the powers. Is equal to 8 times x. We also have equal base to have minus 1 over 2 plus 1 over 2. That's it. Multiplication. Add all their powers. Now understand that this is over 1. So I'm going to have this as x raised to the power what? Now listen carefully. The LCM of 2 and 1 is 2. So we put down 2 here as our new denominator. 2 divided by 1 is 2, and 2 times 1 is 2. Plus 2 divided by 2 is 1. 1 times 1 is 1. This will be equal to 8 multiplied by s raised to the power plus 1 over 2 is 0. Minus 1 over 2 plus 1 over 2 is 0. 1 plus 1 minus 1 plus 1 is 0. So minus 1 over 2 plus 1 over 2 is equals to 0. So all we just need to have now is that this guy is 0. And understand that in mathematics, anything raised to the power of 0 is 1. So this will have given us s raised to the power 3 over 2 is equal to what? 8 times 1. S raised to the power 0 is 1. And we proved this in one of the questions we solved earlier, right? This is it. So the next thing we do, we have this as s raised to the power 3 over 2 is equal to 8 times 1 is 8. Now let's go. At this point, now what do? I need to remove the power of x. So to remove the power of x, we are going to solve this the same way we solved example 2. And what must we do? We now multiply the powers in both sides by the reciprocal of the existing power here. Are we there? So we'll now say multiply the powers of both sides by inverse of this will be what? 2/3. That's how you clear off powers when they are in fractional form. Just invert it. Then this will have given us x raised to the power 3/2 multiplied by 2/3. This is what we are multiplying the power of both sides with. Is equal to 8 raised to the power. Don't forget that the power of this is 1 multiplied by what? 2/3. And guys, 2 will cancel 2 all the way. You can multiply out. 3 times 2 is 6 and 2 times 3 is also 6. And this will have given us 8 raised to the power 2/3. Now at this point, 6 divided by 6 is 1. And now this we obey the what? The seventh law of indices, fraction. Because this is a number. So I have to do is to create the cube root of 8 all squared. Now the cube root of 8 is a number that multiplies itself 3 times to give us 8, and that will give us 2. So this will have given us x raised to the power 1, will have given us 2 raised to the power 2. X will have given us 2 raised to the power 2 is 4. 2 raised to the power 2 is 4 multiplied by 4. So this is the answer to this very question. So in another video, I will teach you the shortcut to solving problems of this nature, right? That in 2-3 lines we will be able to provide the required answer. I'll show you that in the next video. Alright? See you guys in the next video. Thanks for watching. Don't forget